Our next session, I'm going to introduce our folks here. Jay Naves is a senior solutions architect supporting aerospace and satellite customers at Amazon Web Services with edge computing in space. In this role, he led the technical deployment of an AWS snow cone to the International Space Station for use as an edge compute device, and at the time of writing, continues to manage its operation. He's an expert in Linux systems administration, and prior to joining Amazon Web Services, spent 20 years creating and leading high-performance compute systems and security teams at General Dynamics IT. Jay Naves. Wave, let him know.
Thank you.
That's you. All right, and Keith Martin. He is a senior solutions architect and for aerospace and satellite solutions. And as a solutions architect, Keith brings more than 2 decades of brand IT experience ranging from software engineering to enterprise strategy. With a focus on operational efficiency, Keith has been with AWS for 3 years, focusing on migrating complex workloads to AWS. Prior to joining Amazon Web Services, Keith helped drive a culture of automation at a Fortune 100 oil and gas company and brings significant prior experience from his time at NASA's Johnson Space Flight Center, where he led the initial modernization effort to virtualize mission control for ISS. Keith has a BS in aerospace engineering from Embry-Riddle Aeronautical University and an MS in software engineering from the University of Houston Clear Lake, as well as multiple Amazon Web certifications. Keith, all right. I'm going to turn it over to you.
Yeah, thank you very much. All right. Thank you, everybody, for coming today. I really appreciate everybody joining us this afternoon. And we're going to get on the right one. Thank you very much for the introductions. I really appreciate that. Hopefully everybody's a little awake from our coffee break after lunch. So we're going to just go ahead and jump right on in. So this is going to be our agenda for today. It's got a number of items that are on there, but for the most part, they flow fairly sequentially. We start talking a little bit about what AWS actually brings to the table with the number of partners and customers that we actually have in the space field today. And we'll walk through some of the use cases that we have. Some of them are actually deployed today. Some of them are more the art of the possible and things that we're thinking are either in flight or, bad analogy for the space industry, in the process of being developed or actually more of an opportunity to be able to build. So as we walk through all of those, we're going to go through, given that it's an AI conference, we're going to talk a little bit about what some of the AI offerings are from an AWS perspective. This isn't a sales presentation. We're really just trying to get out there and demonstrate what some of that technology brings to the table in order to be able to leverage that in your everyday strategies, both from your business perspective or just if you're out there to learn. And then as we walk through some of those things, we're going to actually give you an interesting demonstration of how to be able to factor in some generative AI capability. And then we're going to close that out with some more hands-on actual as-flown for ISS partnerships that we've done with AWS. And then we're going to close out the overall session. We have a generative AI project that has a space theme. So anybody that would like to generate a postcard from Huntsville, we actually have a Gen AI app that will actually, you can kind of pick your theme of what you want to be able to do and use a Gen AI prompt to be able to generate a postcard, and then you can send that on in. So with that.
Computer, this is Captain James Kirk of the USS Enterprise. Destruct sequence 1, code 1, 1A.
Voice and code.
Okay, so while we obviously didn't encode a self-destruct sequence in the Alexa device that flew on the Orion, I meant to point out that on the screen when you guys were joining us, we had the dates that the Alexa device flew on the Orion capsule, and it went out to the moon, orbited the moon for 16 days, I forget what it was, and came back. But again, while we didn't have a self-destruct sequence on the Alexa device, we had We did set out in mind to accomplish several objectives. The first, and the reason behind Captain Kirk, his discussion with the computer, was because ex-Amazon CEO Jeff Bezos had a lifelong dream to build something. The inspiration behind the first Echo was this voice-based computer from Star Trek. And so that was the inspiration behind the first Echo device. The other, let's see if I can get this to work. All right. The next accomplishment that we had was what we like to consider in Amazon AWS is working backwards from the customer. That's one of our paradigms. So we talked to NASA, we talked to astronauts, we figured out what the needs were, and we started working backwards from customers' needs. One of the first stories we started hearing when we were talking to astronauts were anecdotes about problems they were having, scenarios they found themselves in. Say, for example, this scenario that you see behind me. Picture yourself, an astronaut floating around in this environment, and think about how productive, how helpful it would be to have a digital voice assistant baked into this stuff, right? So one anecdote we heard was astronauts can sometimes find themselves floating over to a keyboard or unconsciously. They don't think about bracing themselves, and quite literally the kinetic energy from the keystrokes rebound their hands away from the laptops, and they'll float away. And it doesn't sound like a huge problem, right? But it's annoying, I'm sure. That was one anecdote that we heard. So we thought it would be very helpful to have a digital voice assistant in space-based scenarios like this. Another scenario that you see here is most of the astronauts that go up, they're running these science experiments nonstop. They have what they call a knee board, that little whiteboard that has a pin in it, right? And it's Velcroed to their pant leg. One astronaut, Mark Kelly, the guy you see up here, told us about a scenario where he was floating around. I think he's got a video camera or something, and he's doing a science experiment, and he drops in microgravity, so that's a relative term, but his knee board floats away. And I think he can't let go of whatever experiment that he was doing. So he literally takes the pen and he writes on his pant leg all the notes that he needed. And he said, well, it would have been really nice just to say, I'm not going to say it in case there's one in here, but a word, take a note. These are the things that I need to do, or the things that I accomplished, put in the system, that kind of thing. Okay, so the next accomplishment that we set out to do was the harsh environment. So build Alexa to operate in a harsh environment. So Alexas that you sit on your desk at home, they're not intended for harsh environments, so that was a problem for us, right, to make this thing work. So the Alexa device flying inside of the Orion capsule it wasn't built to withstand a vacuum of space or that type of thing, because the Alexa flew in the capsule, which is what NASA calls shirt sleeve environment, where the astronauts live and work. So there's minimum radiation. But we did have to build this device custom for the Orion capsule with the idea in mind that it had to withstand the massive amount of vibration and shock, for this thing launching up, into space. It had to be designed to not be combustible, not to emit any type of gases that were harmful. It had to withstand electromagnetic interference from other payloads. It had to be proven out that it did not emit electromagnetic interference to interfere with other payloads. So that was quite an adventure. One other thing that we had to do for this mission was an Alexa device typically sits on your desk, or wherever, right? And you say something to it directly. You interface with this thing, and it responds back. But what you don't know is, typically speaking, it phones home, it gets information from Alexa, the cloud, and it does a lot of the heavy lifting in the background and sends results back. So So obviously in space, we didn't want to have Alexa do, that phoning of home when we're looking outwards towards like deep space missions. That's not going to be possible, right? So we developed something called local voice control. And so it baked in all the natural language processing, the types of things that are typically the heavy lifting done, in the cloud compute environment that Alexa gives you. So we baked that in as well. Another challenge that I kind of hinted on was no crew. So Alexa is typically designed to have you sit at it, and it has a microphone and one speaker, right? It hears you, and then it says something back to you. Well, in this environment, there wasn't an astronaut in the Orion capsule that went around the moon. It was just a demonstration, right? And so we had to build a custom Alexa device that had both the speaker that spoke what the person sitting in Johnson and Houston, I'll go over that a little bit here in a moment, but someone in Houston said something to the Alexa device sitting in Houston. It was read out of a speaker on the left, and then that output was picked up by a mic on the device that Alexa then, in turn, computed, used the local voice compute to do whatever it is that the person asked it to do, right? And then it read back the response. If it was an audible response, it read it back out of the right speaker that you see there. We also had it do things like change the cabin lights. We'd change the cabin lights from to pink or red or whatever. We did some meaningful interactions with the capsule itself too. And then the dots on the circles on the right were the microphone that picked up Alexa saying what it was saying. So it was an interesting, odd challenge. I meant to mention, this is one of the very first whiteboarding sessions that our UX designers had when we started putting this out there. Like, it's never been done before, so how does this work? And it turns out, this is one of the last prototypes we did before we installed it in the Orion capsule. It ended up looking very much like that drawing that you saw on the whiteboard. So this is the actual installed Alexa device in the Orion capsule. It flew late 2022, 25 days. This is not an astronaut, it's a dummy, just for illustrative purposes. But this was a large, long-term project with multiple companies: Lockheed Martin, WebEx, Amazon, AWS, NASA, of course. But this is what it looked like installed into the Orion capsule. So another challenge with not having someone there physically standing at the Alexa device is we had to have a place where people came and told the Alexa to do something. So we worked with NASA, Johnson Space Center in Houston, and we built an actual mission control center. It's just a room in Johnson Space Center where we invited STEM scientists, celebrities, a number of different type of persona to come and interact with Alexa. 25,000? 250,000. 250,000 miles away. I think the furthest it was 258,000 miles, I believe. So this is kind of how that interaction looked, right? So you had somebody sitting at Mission Control Center, would say something to Alexa on the Orion capsule. Alexa would then interact with the crew member, the dummy, and then it would respond back to Mission Control Center so that they could hear their response, right? Here's a little 10-second clip that I found amusing. This is a pair of STEM teachers, I forget where, I think the Clear Lake area in Houston, that we invited to come and interact with Alexa 250,000 miles away.
Alexa, tell a science joke.
Alexa, tell a science joke.
There's a fine line between a numerator and a denominator.
All right. So yeah, I thought that was very amusing. Hopefully you guys did too. And that was an actual interaction. That wasn't dummy, that wasn't made up. That STEM teacher, Then it's a long video, you can find it online, where they had interaction with Orion, or, with Alexa floating out 250,000 miles away. So this last clip is a little 20-second clip that I find personally inspiring. I'll make a comment after it. But this is a little video that Amazon AWS put out prior to the Alexa device going on orbit.
How many stars are there in the sky?
It depends on where you are on the planet, but there are 100 billion stars in our galaxy.
Alexa, how cold is outer space?
Outer space is generally around negative 455 degrees Fahrenheit.
Alexa, can we go to space?
Sure, welcome aboard Orion.
Alexa, what do we eat in space?
Grandma!
So 2 things I'll point out. The first one is I have literally watched that video probably 20 times, and I don't know why. Maybe it's surreal for me, but when the mom says, "Can we go to the moon?" I swear I have the hair on the back of my neck stands up every time. I don't know why. It's just kind of very inspirational for me. But the other thing is, you should have seen a moment ago, it said, Alexa, take me to the moon. So if anybody wants to hear more about this, if you have an Alexa device, know anybody with an Aware device, just go walk up to it. I've done this like at the barbershop too, but say, Alexa, take me to the moon, and it'll tell you, I think it's like a 30-second spiel, right? But it's really cool, I think at least. All right, so as Keith mentioned, we have little short Q&A sessions, 2 or 3 minutes, maybe, just in case anybody has a question, specific to this particular story that we have. Does anyone want to ask a question? You don't have to, no pressure.
I'd just like to ask that when we're gearing up for the next flight of Orion, rather than being in Houston, you come back to Huntsville and we set that up in Mission Control and Space Camp, and we can have the Space Camp students say, Orion, Alexa, take us to the moon, because I think our Space Camp trainees would get in a discussion with Alexa. So.
Okay, well, I'm a Huntsville native. I'm born and raised here, so I will definitely advocate for that. Can't make any promises. We can't talk about future projects, but ask this guy all you want about, like talking to Alexa. He's always asking Alexa about what a black hole is. What's the, anyway. But yeah, I will definitely do that. Cool. All right, so this next little short spot is where we're going to just talk about art of the possible, talk about a lot of different use cases that Amazon Web Services as a cloud computing provider outfits companies, provides tools, services, resources, so that you can do some of this cool stuff, right? So this is you. I'll let you take it.
Yeah, I apologize. We actually had a third member who he fell gravely ill right before we ended up talking. So we've shuffled around our parts. So hopefully there's enough continuity to be able to hide through that fact. But Mirza, we wish you well. Good luck, buddy. But really, one of the things that's really interesting is just the sheer growth of the space industry. And if you really look back, 2022 alone had more than the previous 52 years worth of launches. And the rate of launch has only increased. So I apologize, I don't have the 2023 statistic, but there you go, 223 launches just in 2023. 2024 has already started off. There's already been a significant number of launches that are out there. So I have friends with payloads on the way to the moon right now. Intuitive Machines has just gotten their lander out there, so wish them luck as well. But interestingly, of the 12,000 or so companies that are actually around the world, about 56% of those are actually based in the US when we deal with space. So a lot of that industry is actually close to home. So, I mean, as we just talked, Huntsville is very busy in space. So being able to understand how to be able to connect to your partners, how to be able to connect to your customers is really important, particularly as you look at that third statistic of, current spend is about $4.5 trillion on space. looking forward just not even 10 years, it's supposed to be $10 trillion. That's a significant investment in being able to actually build more, do more, just get more to space. And then the last statistic that I find to be almost frightening is the number of orbiting bodies. So right now there's about 7,000 orbiting bodies that are out there. We're looking to be able to grow that overall number by 2030 to 65,000. And anybody that's out there paying attention to things like Starlink or Kuiper understands exactly why that number is growing to what it's growing to. So a lot of that growth, a lot of that opportunity is in front of us. We really are very early in the overall days of figuring out how do we do traffic management on that many objects. So as we start to look forward and try to understand where technology fits into some of this, that's really where use cases of AI really start to grow. And I'm gonna call out a couple of these. There's some very distinct themes. A lot of this ends up from an Earth observation perspective being based on the kind of sensors that are being used. So Earth observation is kind of a very broad category, and depending on what sensor package, some of the signals actually penetrate into organic material. So you can do things like very smart agricultural management. Some of them are like more weather-based, the normal satellite imagery that you see. So depending on how much technology has been infused into the particular mission that you're up to, that really derives what kind of use cases you can use. So when you really start looking at being able to expand those out, a lot of that technology that's been inserted now gives us the opportunity to be able to do like synthetic aperture radar, where you can actually take day-over-day imaging of things like train tracks. So that way you can actually see, like, are the rail lines impeded without actually having to send anybody to these remote areas. So as you actually start to look at just the radical increase in the number of space devices out there, that is also an exponential increase in the amount of data that you have to process. All of that data has to get processed somewhere. What better way than to pull it back to the ground and actually use some AI to process? And then the last piece is that space situational awareness. That 60,000 or so satellites that we're going to have to try to plan and navigate around, that's really going to be a great area for us to be able to lean into. There's a lot of really complex math, a lot of really complex physics to be able to make sure that all of those satellites are actually going to orbit the right way, that they're actually going to be able to deorbit in a safe manner so that way we don't create even more space junk. So, hand that one to you.
Okay. Yeah, Keith just mentioned space situational awareness. One thing that I find interesting, I was at the Space and Missile Defense Symposium here in Huntsville because I'm a native, and I think it's General Dickinson, right? He was mentioning, all the different IT uses, compute uses for the DoD, for Space Force, Space Command, and someone, it might have been me, asked him, what do you see as the biggest risk in technology for Space Command and Space Force? And he said very emphatically, no question asked, space domain awareness, space situational awareness. Knowing what's up there, knowing how to defend against it, knowing, when it's coming at you, that kind of thing. So it's very applicable here for, Huntsville for sure. Cybersecurity is very applicable here for Huntsville too, with the cybersecurity school. Cybersecurity for space, you think about it and it doesn't seem like it'd be that important, but it is. It's actually a growing concern. Now you're talking about not 7,000 devices, space-based assets, but 65,000 space-based assets to attack. And think about all the different resources that we rely on, that are in space. If those come under attack, cyber attack, it's very critical. So we work very closely with a bunch of companies in that particular area. It's funny that DEF CON in Las Vegas, they have a defense, DEF CON, it's a security thing in Las Vegas every year. Last year they had a hackasat. So they had a hackasat marathon where they invited like 5 or 10 different groups of individuals to literally hack a satellite that they put on orbit. I forget what it's called, but Moonshot or something maybe. But so I think the winner, the first group to hack that satellite won like $50,000 or something. But it was a literal space-based asset satellite that was, designed in a way that mimics as closely as they could to a real space-based asset to figure out where the vulnerabilities lie, and so they can start plugging some of these holes. So the other one that I want to talk about is space traffic management. We work with multiple customers in this area as well, and it kind of goes, it's tangential away from the space situational awareness too, but there's a company that just literally launched a satellite into space now, designed to, it has a rocket body that is on orbit, currently defunct, is sitting and floating in space, not doing anything, and the intent is to have this satellite approach the object, determine, how the best path, whatever, line it up, basically figure out how to grab that object and start to take it away out of the important orbit, put it in an unimportant orbit, that kind of thing. And I think they have intentions to deorbit these things eventually. I don't know what all it's going to do, but this is a really cool area of growth for us. I think you have the next two.
One of the other really interesting pieces, particularly as you start looking at the number of communication satellites, communications is like a really big deal. And with things like Starlink and Kuiper up there, craft-to-craft communication now gives you the opportunity to do things like mesh networking. Mesh networking over a space-based network. That way you can actually use things like AI to crunch what your current, what your current availability is from an in-space asset. Do you actually provide opportunity to be able to bring that down over a terrestrial network? How do you actually figure out all of those routing protocols? SD-WANs are a really big option to be able to get higher performing networks in a way that are configurable and controllable. Once you actually start adding a space mesh to that, the number of permutations becomes significantly larger. So again, this is a great use case to be able to throw those kinds of problem spaces into AI, so that way you can actually have an operating network that is ignorant of whether you're using a terrestrial-based network or a space-based mesh. The last piece, Jay kind of mentioned it a little bit, and we're going to walk through another scenario. Using natural language processing is a really key aspect as you get into some of those more obtuse environments like zero-G. So all of the things that we take for granted, being able to just pull out our phone and be able to type away or find a keyboard and tap away, those aren't necessarily the easiest things to be able to do. So how do you be able to take that natural language processing and really extend that into more of a conversational aspect? So what I really want to do, I think I actually skipped through, I'm going to skip through this. We have an eye candy chart these are all of our current partners or customers that are currently on the AWS platform or are contributing to AWS partner relationships. I don't want to undersell any of these. I can't give you any concrete examples on how we're partnering with these, but if you want to talk to me after, we can absolutely dive in if there's any that jump out to you. But where we're really looking to go is I want to be able to transition you into a better strategy of what, from an AWS lens perspective, of getting into AI in general and generative AI specifically. Because we're out at a conference for AI, but how many people have actually gone and played around with like ChatGPT or Bard, or we're at like 95%. So great, I really appreciate that. So how many people can actually have like a consistent definition of what Gen AI is? How many people feel confident in being able to give a consistent definition of what Gen AI is? I don't know. It seems to be everywhere. It seems to be everything to everybody, but I don't know if there's like a good definition or a bad definition. There's definitely good use cases. There's definitely use cases that I don't see, but maybe that's just because I don't see what's coming tomorrow. But beyond that, if you're really starting to, if you're really starting to understand how Gen AI can help, because all of the buzzwords tell you it should be able to help, where do you get started? How do you know how to be able to get started? There's a ton of tools that are out there. There's a ton of documentation that's out there. There's a ton of people that say they've got it all figured out. If you can find them, please send them to me, because I would love to be able to understand a little better about how they crack that nut. But I'm going to walk you through how I managed to at least get a better understanding of what some of the offerings are, just by playing around. So I'm going to give you all of my lessons because it was fun, and I think it's really an opportunity to understand what the technology can be envisioned to do and what some of those shortcomings are as we see it develop and evolve as we're moving forward. So I'm going to walk you through how do you get started. You know, if you don't know where to get started, probably the best way to get started is just, you know, head over to someone's hosted AI playground. I'm not sure this is actually working. It is? All right, sorry. So as you know, basically everybody raised their hand. Everybody's been out and played with somebody else's chatbot playground out there. Amazon actually has one as well. This is actually, it's called Party Rock. Where they came up with the name, I'm not really sure. But what's most interesting to this one is it's basically a catalog curated by both Amazon as well as other community members. You can create an account, you can go look at it. It's like mini projects of Gen AI building blocks. So you can take someone else's project and build on it, or you can use that as kind of a model and start from scratch. But it's really an opportunity to be able to see what some of the art of the possible is without having a lot of commitment, without having to own anything or anything like that. So you can really do a lot of really creative things in there, but a lot of that customization that you might be interested in, or doing private data set training, those really start to be a little cumbersome when you're using somebody else's hosted model. I don't trust anybody else with my data. I'm hoping that you have the same kind of questions when you're trying to figure out where you want to put your data. So if this ends up running, you know, short of what your expectation is, the next best thing I would recommend is create an account over at AWS. You can actually go in the console. We have free tier that's in there. There's a lot of opportunity for you to be able to play around with some of the technology. Get your hands dirty. This is really the best way to get started, is to just try something. It's going to be a very iterative process because you don't know what model to use, very likely. You don't know what data set to use. You don't know what your problem space is, but you know that you have an idea that you'd like to try to challenge and solve. So head over to the AWS console. If you head over to the Bedrock section, which is the AWS hosted generative AI framework, we've partnered both internal to AWS as well as a number of third parties to be able to have quite a litany of additional LLM models that are out there. You can enable those in your account, and you can actually head over. On the left-hand side, about halfway down, we also have a playground. But what's most interesting in the playground that's available in the AWS console, there's a chat bot, there's a text bot, and an image one, is that on the right-hand side, you can actually start to adjust some of those hyperparameters to really understand how some of those really affect your response data that you're getting back from those prompts. So from a prompt perspective, I mean, how you understanding how to drive what you're asking the LLM is an art in and of itself. Prompt engineering is going to be a big engineering feat, because the better you can actually articulate your problem space in the terms that the model that you're interested in, the better you're going to be able to understand your results quicker. So understanding whether it's going to work or not, just get started. So once you actually have played around with the playground a little bit, you're going to quickly realize, okay, well, this is neat. I still don't know what model I want to use. Well, it turns out that we have a solution for this too. So we actually have a number of sample projects that are out there that you can actually deploy into your AWS console. It's an infrastructure as code project, which will actually build a little web app, and it will configure Bedrock under the covers to be able to create you a multi-model chatbot. So with that one chatbot, you can actually walk through, configure a bunch of different models, and ask a single question and watch all of the different models respond however they see fit. So I'm going to actually, if you actually are looking at the screen, I spent a lot of time asking the models about black holes, about spinning black holes and non-spinning black holes, and what an event horizon is, and what's a Schwarzschild radius. I'm sorry, I'm kind of a techie geek. I'm actually a Space Camp alum as well, so anyway, this is really interesting stuff, because I don't even know what to ask. I didn't know, when I started trying to figure out what I wanted to talk about, I didn't even know what I wanted to ask. And I just got started asking random questions, and it turned into something that was actually quite fun. One thing I will point out, if you're looking at your LLMs to do good complex math for you, I would caution you to not use that as investing advice at the current time, just because if you look at the differences, I think I clipped it off. One of the models says you can get 2 miles away from a black hole the size of our sun before you can't escape. And then the other one, it's down here, it said you had to be at least 2 million miles away. So that's a pretty big difference as to whether you're going to go in the black hole or not. So I wouldn't trust it right now. But so what I ended up doing, because I don't trust the demo gods and I didn't know how good our internet was going to be, I actually pre-recorded me configuring a multi-model chatbot to just ask it a couple of softball questions. So what I did is I head over to that web app that's on the left-hand side. I picked a couple of models. One really interesting thing with this particular model is it actually exposes the opportunity to have a retrieval augmented generation data set. So I actually created a private training data set as well. Just for fun, I decided to add yet a third model to my prompt. So go through, configure him, make sure I added him to the RAG workspace as well. And then, so after all that, I just decided to throw out a few softball questions. So my softball question number 1 is, what is AI Symposium? So with that, I'll let it think about it. You can see that each of the models actually seems to do a pretty good job of streaming an initial response. But as the models actually get through and start being ready to give you everything they want, they have a fairly different length of response. But all of them are actually in context. So I'll send it another softball of what is Amazon Web Services. So the first question I asked, what is the AI Symposium, then got factored into the context of what is Amazon Web Services. And it turns out that it knows that Jay is talking at the AI Symposium. And interestingly enough, one of the other pieces that you can do in this particular demo is you can have a private data set. So I actually have a private data set that Jeff Carver, he was supposed to be here today. Unfortunately, he's not here, but he only exists in my private data training set. So I can ask all of the LLMs that are out there who Jeff is. They don't have any idea from the normal training data, but from my private data set, they are able to actually pull in context who Jeff is supposed to be. So with that, it's really interesting because I might get a better understanding of how I want to be able to use my models. I might not, but it was fun to play along with. And if you notice, it took maybe 10 minutes to deploy everything into the account. And it's really a good and easy opportunity to be able to verify just how vastly different each of the models' response comes back. So again, this is an iterative process. I would highly advocate, get in there, get your hands dirty. There's no wrong way to get started. So just jump right on in. RAG is retrieval augmentation generation. So interestingly enough, what happens with RAG in this case is that it will take your initial prompt and a response from that and then feed that back into the model in order to be able to refine its answers. So if anybody went to security burritos versus security blankets, she did a good job of explaining an LLM is just probabilistic math. It's basically word salad based on what's the next best option to give you back in the context of the prompt that you're providing. It doesn't actually have any sort of sentient knowledge, but statistically, this is a great combination of words that I can give you that will answer your prompt. Is it right? Is it not right? I don't know. You have to actually put guardrails or put some process in place to be able to validate that. So, all right. This is probably a pretty good stopping point to be able to see if anybody has any questions. All right. Sorry.
Yeah, it comes in and out a little bit.
I'm sorry.
No, you're good. So looking at the amount of satellite traffic that you're projecting going from 7,000 to 65,000, the amount of sensor data you're looking at moving up and down, I'm assuming transferring that data is going to be an issue to a certain point. Do you guys have outlook or have you had thoughts about, or what are your ideas around moving some of that compute up to the satellite as opposed to moving the data around?
Are you prescient? Because that's actually part of what Jay is going to close us out with. So I will defer your question for a little bit because we actually do talk about some details associated with that. But I greatly appreciate you thinking ahead like that. So, all right. So To continue on with the chatbot conversation, just because this is a practical and concrete example, I'm going to actually steal. I'm sorry. It's very difficult. There's no way to be able to see what's actually on the deck. So what I want to really be able to do is say, okay, hey, it's neat. Chatbots are cool, but what really comes next? How do I turn that into like a real business process? So as I already said, it's just an iterative process. You really just need to get going. So what I'm going to actually jump into is I'm going to steal Jay's example. This is the astronaut from the space station that his board floated away, and he wanted to be able to still take notes because his time is very expensive. So I'm going to take the conversational chatbot strategy, and I'm going to turn it into a real-world experience. Because one of the things that I really want to be able to do is I'm a naive person on the ground. I see that Jay just described this really interesting problem space for an astronaut. I don't know if it's going to be a good idea. I don't know if it's going to be a bad idea, but I have an idea that maybe he should use a conversational chatbot to be able to interact with his inventory management system or take notes. So what I really want to be able to do is, using that fairly fictitious example, of walk through what Amazon actually sees as an opportunity to be able to reduce some of that toil, increase some of that developer efficiency by actually stacking generative AI into overall workflows. And what I really want to be able to do is, it's a conversational chatbot. I want to use natural language. Great. AWS has a service for that called Lex. But on top of that, because I don't know if it's a good idea, I don't want to invest a whole lot of time from a proof of concept perspective. And I actually want to be able to describe my problem space in as natural of a language as possible. So it just so happens that with Amazon releasing Bedrock, the Lex service team has actually decided that they're going to be able to create an ability for you to create higher level services and configure those using a generative AI prompt-based strategy. So I'm going to walk you through that right now. So you head over to that Amazon account that you created, you head over in the console, you go to Lex. The first thing you see is that giant banner that says, hey, we're now Gen AI enabled if you use Bedrock. Bedrock was already enabled because we just did that multi-model chatbot. So sounds like we're in the right spot. I click that big orange button, Create Bot. The first thing that I end up landing on is a page that says, hey, there's a descriptive bot builder. And that sounds like the use case that I want, because I think I have a good idea. I don't want to invest a whole lot of time because I don't know if it's going to pan out yet. So let's give that a try. And fill out a couple of details, but then I get to this page that actually says, describe your use case. So, hey, this sounds exactly like being able to be an area where prompt engineering would come into really handy to describe my problem space. So I pulled together a prompt. I'm actually going to walk you through the prompt that I came up with. It is a little long, but all I ended up doing, and to be fair, this is about the third iteration I came through, but in natural language, I want to describe my problem space. So I highlighted a number of things on the slide here because I want to point those out, because as we walk through the actual creation process, they're all going to become very important. From a data model perspective, I want to do inventory management. So I need to keep track of items. I need to keep track of how many. I need to know where they are. And because I thought it would be fun, I want to know when they expire, because the last thing I want to be able to do is feed an astronaut an expired product. So no problem. But from an inventory management system, it only makes sense if you can add stuff to the inventory. You can count how many you have in a particular location. You can count how many you have across all your locations. You can move items from one location to another. You can remove items because maybe I ate the candy bar. And I want to be able to also list all the items in my inventory with an approaching expiration date. So again, I didn't spend a whole lot of time trying to come up with what my prompt is, but it feels like I've gone fairly descriptive in understanding whether this is going to be usable or not. And one of the things that I found in my previous iterations was Lex tries to be really smart as it reads through my natural language paragraph. Items like locations, it thinks are going to be like cities or states. So I want to override that in my description because I'm on the space station. It's like cabinets and drawers and things like that. So I wanted to basically just tell it, nah, ignore what you think it's going to be, use what I'm going to tell it. And because it's all in space, I want the prompts to be as short and concise as possible. I want to be able to interact with this thing with as few words as possible. So I take that prompt, I send it in, and my clicker doesn't work all the time. So it thinks about it. Again, the demo gods, I didn't trust them. This process actually takes about 2 minutes for it to think. takes my paragraph, it actually dissects it, and gives me a page that actually gives me a breakdown of all of the things that it thinks it distilled from my natural language paragraph. And the reason that I color-coded that was in red were all of the actions that I wanted to be able to use to interact with the system. On this particular page, in Lex terminology, an intent is basically an action. It's one of the reasons that I want to interact with the overall system. And if you look, there's 6 intentions that are listed: add, check, count, list, move, remove. Hey, it looks like it actually pulled out all of the red items. All right, looks like we're doing pretty good. That second column is actually where all of the value of the Gen AI process comes to bear. And in Lex speak, an utterance is basically a phrase that you use to interact with the system. And this is really, based on that paragraph, Lex was able to come up with 10 sample phrases for me to interact with the chatbot on my behalf for each one of those actions. So now I have 60 different combinations of phrases that I would have had to spend to go and figure out prompt engineering. Well, how do I want to ask to add an item? And so it did it on my behalf. Again, it took about 2 minutes. And then that last column is of interest as well, because from a parameterization perspective, Lex calls those slots. If you remember back to what we highlighted on the previous slide, for my data model, I had 4 items. So I'm going to jump to a little more detail on this to give you a breakdown, but for generated slots on add item, I need item name, I need quantity, I need location, and an expiration date. Those are 4 parameters. It actually claims that it found 4 slots to be able to fill. So I'm going to pick on add item just because it's the easiest one. There you go. Pick on that. That'll actually list off all of the different phrases that you can interact with the system. So if you look at them, the parameters are actually in braces. And then if I scroll down a little bit, I'm going to dive into a little bit about these slot types, because expiration date, if you notice, it actually came back with a date. So not only does it know expiration as a parameter, it actually correctly attributed what the data type is. The next item is item name. Of course, it's just an alphanumeric. I didn't give it any rules. But because I told location is not a city or a state, it actually just turned that one into an alphanumeric as well. And the last one, it properly determined that quantity is actually a number. So for each of the actions, you can actually go and verify that the system by default plucked out of your paragraph all of the ones that you want. You can obviously remove some of them, you can add some more, but from a proof of concept perspective, I'm only in it about as much time as it took me to create the prompt. So I'm at, maybe 10, 15 minutes before I can really understand whether my natural language chatbot can actually bring to bear anything of value. So the next thing you have to do is you have to actually build the bot in order to be able to test it. So I sent it off, it builds in about 2 minutes, and then once it's built, it actually gives me a little green bar across the top and says I can test. So at this point, given that I've picked on the add item intent, I'm going to actually drill into him again. I scroll down a little bit, and it actually lists off all of the individual phrases that you can actually interact with by my conversational chatbot. I'm going to actually pick on that second one down. I want to add item name to my inventory. So on the right-hand side, I really wanted to do this interactively, but, well, I wanted you to actually see a productive result. So I'm going to put in there, I want to add bananas. I love bananas. I want to add bananas to my inventory. So I put that into my test screen, and it actually comes back with a question. It says, I put a phrase in that only had one of my parameters of 4. So I didn't do any of the additional prompt creation or generation or any of that, which would be typically required on how you would deal with an interactive chatbot. It knows that I have 3 more parameters that are required in order to be able to fulfill that action. So it actually will walk me through prompts for each of those additional actions. So I say I want 4 of those, and then I want to put it in the app storage, and then what's the expiration date? So it has properly walked me through all of the different parameters in order to get me to the end state. Now, I haven't put in there yet that for my expiration date, I want next Tuesday. Next Tuesday feels like a great natural language date. but it's just that. It's a natural language date. So instead of having to actually represent that as like a calendar date or something that's easier to parse, next Tuesday sounds like a great opportunity to be able to prove that that data type that we looked at actually matches to be able to use a natural language response to give me a date. So if I were to have filled any of that out incorrectly, what would have happened is I've gotten the default, what is it called? The fallback intent. The fallback intent is basically the, oops, I don't know, something went wrong, start over. If I actually end up triggering this the right way, what I get back out of the test is intent add item has been fulfilled. So if I send next Tuesday in there, I actually get back intent add item fulfilled. So at this point, all I've done is created a paragraph that describes how to be able to deal with inventory management, and I've been able to ask it a number of questions and have it respond in a way that actually makes sense to me. In a real world scenario, I would actually hook this to like a real backend that would model an actual inventory. I would actually hook this to an audio device to be able to have natural language conversation just like you would with an Alexa. But at this point, is this enough for me to be able to go to somebody with a straw man that says, hey, I have an idea. Does it work? Is it enough? Is it going to get me where I want to go? That's really what some of the benefit of Gen AI is being able to reduce some of that toil. Code Whisperer, Code Pilot, things of that nature, those are all great opportunities to be able to reduce the toil of a developer. But when you start adding higher level services to other components, you really start to see the value proposition because did it hallucinate? Well, maybe, but I can see how it hallucinated because I can actually verify through each of all of the phrases that it came back with. I can look at it. I can validate the answers that it gave. So with that, I'm going to close out my actual chat demo here and see if you guys have any questions. But remember, as you're starting to get forward, the sky is no longer the limit. It's really space. So I really appreciate your time so far. I'm going to hand it back to Jay. Is there any questions that we have so far before we kind of give some more real-world examples?
So with the example that you just showed us, is it actually going out and building like a database or putting that information anywhere, or do you have to do additional work from there to actually use that data?
You have to do additional work, but again, from a straw man perspective, understanding how to interface with your inventory management system, understanding what that data model actually is, understanding how to interact with the person is like the user experience aspect. So a lot of projects are dead before they get going because that user experience isn't something that's actually going to move the project forward. Understanding how to do data modeling and actual interaction with a data warehouse or whatever you're going to hook as the back end is left to the reader. But again, all of the heavy lifting from an interaction perspective has been taken care of. So one of the pieces that I kind of skipped over is even though you built it all in the console, it feels like it's ClickOps, it's not infrastructure as code. You can absolutely export all of the Lex products and include that in your CI/CD pipeline, so you can just include it as your normal delivery cycle. So you might have built it in the console, but yeah, you can put it back in as infrastructure as code without any issue at all. So.
Thank you.
All right.
Okay, so how are we doing for time? I'm having a hard time. What time do we start, guys? Was it 10 minutes?
We have about 30 minutes left.
30 minutes, okay. So I'm gonna tell a story about a project that I've had the pleasure to work on for the past 2 years or so where we flew. Keith, would you do me a favor? Can you take that snow cone? There's a AWS snow cone. It is a edge compute device that AWS offers. Anybody sitting here in your chair can go to the console and order one of these things. And we took this, we have one of these on the space station where we do science experiments. And it's ruggedized, so I'm going to hesitate to say you can drop it, but if you do drop it, you don't have to run out of the room, like you're in trouble. So, all right, so the bottom three things that you see here it's a generative AI application that I've got where you have three different things that you could pick from just for fun. You got the ISS, the Saturn V for all of you that are from the Huntsville area, and then the space shuttle as well. And you can choose which one that you want. You can tell it a prompt title that you want at the top. Make sure it's something you'd want to tell grandma, right? Something, no profanity. But then the image in the background is something you can tell it. You can say, give me a picture of Huntsville is what I gave it there. The prompt is a little more complex than that. But this was the moon in the background in space. And then this was Cape Canaveral. So after I'm done, if anybody wants to spend the last 10 minutes or so just talking to us, chatting with us, you can tell us what you want, and I'll show you the demonstration. And you can print out a postcard to take home with you. So I'm going to apologize because I want to back up for 1 second. We meant to do this, and we got out of rhythm. So I'm going to I'm going to risk the demo gods, and we're going to find out if this works. We tested this before the show, but where Keith left off was talking about inventory management. We built a digital twin in a product called AWS IoT Twin Maker, which is an AWS service that allows customers to build a digital twin. And we built a digital twin of the space station, and it is not loading. So Keith jinxed me. I swear we tested this 3 times before we showed up, or before we started the demonstration. But let me make sure that the Twin AI site is going to work. That works. Okay. So I don't know what it is. All right. Apologies. So anyway, I was going to show you, and I'll check it again before we leave. I was going to show you that digital twin of the space station, and when I clicked on it, it would take you to a dashboard of the multi-purpose module in the ISS, Node 2, I believe it is, and in the background you just see like all these, big plastic containers that literally have inventory stuff in it, just thrown in a room in the space station. Left the clicker. All right, so this story is about the AWS snow cone that you're passing around. So what we did is back in 2021, we talked to our customer. One of our customers, Axiom Space, is positioned to replace the International Space Station when the ISS is set to deorbit, go to the Indian Ocean, whatever they decide to do with it, right in the 2035, I forget which time frame. And Axiom Space has a contract with NASA to build a replacement space station, and they're going to build this as an extension from the existing space station. They're already there now. They're working hand in hand with NASA to learn how to be a space station provider. And they're going to build a module. AX-H1 is their first module. It's a habitat module that's going to extend out from the space station. And then they're just going to continue that process and build another space station before they detach from the ISS. And so Axiom Space is a customer of mine, and they came to us with a challenge. How do you learn how to be a space station provider? NASA does it. China does it. Who else do you talk to, right? And so one of the things we talked about was, let's just start with a small demonstration of something that you're going to need, right? Going back to your question. So edge compute, right? So how do you decide, when do you spend the resource, time, and effort to analyze data that you've created on orbit and do that heavy lifting on orbit versus just going ahead and sending it down to where you got racks, got data centers to do that stuff. So there's a trade-off there. So if you can reduce the amount of data that are is insightful, actionable, or what have you, that you want to actually have possession of while you're in orbit, then that's a meaningful use case to do it on orbit and then ship down only 1% or 10% of what you typically would, because getting data up and down on the space station, to and from the station is slow, generally speaking. So we said, let's tackle that, right? And so we started looking at what AWS offers customers for, for something that might fit this need. Well, there's a Snow product line, and the small version of the Snow product line is the Snow Cone, is somewhere floating around here. And then there's a larger version that's about the size of a checked luggage suitcase. And it's quite amusing. Quite often when we go to conferences, whatever, AWS employees will take selfies. I see you back there. Take selfies of themselves pulling one of the Snowball edges off of the conveyor belt. So you literally can walk this up and check it into the American Airlines luggage. And it's like 20 times that size. So it's an interesting product line. So we took the COTS commercial off-the-shelf product that you could order, and we said, let's fly that to the space station. And so that's what we did. It was immediately available. Anyone can do it. We wanted something reproducible, scalable. AWS likes to scale. Here's some quick details about the Snow Cone. You've seen it. You've touched it. 4.5, 5 pounds, something like that. There's a term a lot of you may have seen. It's called SWAP, so size, weight, and power. Those are typically very critical considerations for someone who is deciding on what to launch. Upmassing is hard, it's expensive. The Starship is going to drastically change that. It's already been changed significantly. But deciding what you want to put up is, that swap aspect plays a critical part. And then it's rugged. It's designed to work in these austere environments. There's people walking around with these things in the backpacks and, out in the desert and tents. It's designed to work in that type of austere environment, and what can be more, austere than space, right? So, and then one of the last aspects I'll point out that is atypical, its value prop for Snow is it's designed to work in a DDIO environment, just basically disconnected, intermittent connectivity type environment. So most servers, you have to plug them up, they have to stay online, they do their work. You can't constantly unplug them from the network, and have them just immediately come back online and go, function as normal. The Snow product line is designed to do just that, function autonomously without network connectivity. It doesn't talk home, doesn't talk to the cloud, and it can still do what you want to do. So those are some of the rationale that we used on what we chose. And then the actual work product, the demonstration that we wanted to do, is we didn't want to do just a demonstration for the sake of having a demonstration. So we chose like a real life use case. Johnson Space Center, they have, you can look this up online. They have what they call Building 8. I think it's quite literally labeled Building 8. And they're in charge of doing all the videography, all the imagery that comes out of the space station. And so they take these images and these videos and they filter them. They look for, this wouldn't happen, but a cosmonaut's face, or a random picture someone took of a science experiment that happened to capture a laptop, with proprietary information on it, that type of thing. They vet it for the possibility that it gets delivered to the public for public, consumption. And that's not all they do, but that is one of their major, work efforts. And we decided, hey, that sounds like a perfect thing that the AI, a machine learning model, should be able to do. Why not, do that all on orbit and then just send down the 18% of the photos that should be publicly released and just do away or keep them somewhere else, the photos you don't want to publicly release. So we came up with a demonstration that was meaningful, applicable, not just what's, yeah. So, and so this Snow Cone, we built a machine learning model. We put the machine learning model on the Snow Cone, had an astronaut bungee cord. It's quite funny. It's literally bungee cord. You can see pictures of it to the side of a footbridge on Node 2, I believe, as well, and power this thing up. And it ingested like 840 some odd photos that the commander, mostly of the AX-1 mission, took. There were multiple astronauts that took the photos, but I think he took the vast majority of them. I mentioned AX-1 because the snow cone went up on AX-1, which is Axiom Space's first mission to the space station, and it happens to be the very first all-private mission to the space station. It was the very first time someone launched only private astronauts to the space station, which is, pivotal. So this machine learning model ingested these images. It looked for astronauts' faces, computer screens, things that someone sitting at Building 8 might go, all right, let's flag this and send it for review. And it put it put bounding boxes, is what we call it, around a person's face. It gave it a score. Say it was confident at 98% that this was a human face. So it gave you some level of confidence rating, and then it put a bounding box around it. And it also gave some metadata, JSON image or JSON text data that it sent back as well, so you could just run this through like an automated system. So how did we do this? And this was quite enjoyable for me, but we got to take several trips to Johnson Space Center in Houston. We basically had to certify the snow cone with something that NASA, I think, they basically call it Authority to Operate, ATO, right? And so you have to put your hardware, before you fly it, through this rigorous, pun intended, battery of tests. And the one that you see on the left here is a set of tests that we had to do on the batteries, and in particular, the battery of the Kindle. That white screen that you saw on the snow cone is quite literally a Kindle, e-white, Paperwhite, I forget what model. And this thing is designed, you could sit it in your closet and it'd be, still be charged up 50 years from now. So we had to test that thing, the batteries, we had to discharge it. They don't want things flown, that are fully charged for certain reasons. We had to test the metrics from the batteries and from other, components of the hardware. We had to put the snow cone on. This is I don't think this is in Houston. I forget. Yeah, this was in Houston, a vibration table. This is an X-axis vibration table. We strapped the snow cone to it, and it just shook it in a way that mimics what, the extreme example of a launch condition would be. So it has to test vibration test or pass vibration testing, just like the Alexa device did. The battery testing, those are two important or fun tests that we had to go through. Two more, I think these are the last two examples. The one on the left here is electromagnetic interference or compatibility, I think is what they call it, where we put the snow cone in this shielded room, and we had shielded Ethernet cables, and we tested this thing. Does it emit too much electromagnetic interference? Will it interfere with somebody else's payload because it emits too much? And then also, you'll see test antenna positions. There were emissions of electromagnetic interference at the device. Is your device capable of withstanding, electromagnetic from other payloads? So you had to make sure those aspects weren't going to kill your payload. And then the one that you see over here on the right is we set the snow cone down and underneath a bunch of acoustic booms. We run the snow cone at 100% capacity. Forget what all we did. We basically told it to generate as much noise as it's possibly going to be capable of generating. And I think the limit was 37 A-weighted decibels. If anyone is an acoustic engineer knows what that means, I don't. But tested to make sure it wasn't going to be too loud for astronauts, that it would interfere with other payloads, listening and hearing, doing things, that kind of thing. So, yeah, on April 2022, this thing launched to the space station. This is a picture of it in the cupola, the famous spot where everybody takes their pictures, pretty much. And you'll see the UPS shipping logo, and you'll see where we whited out where it said ship to Amazon Web Services. But that's what you typically have when the snow cone arrives at your desktop. Fun fact is when you take that, it says ship to Naves when I get it, right? And so UPS, they hand it to UPS. UPS knows it goes to me. The second I hit the power button on the thing, it flashes the Kindle Paperwhite, and all of a sudden it says ship to AWS in some location. And so we quite literally get to walk to UPS, hand them this thing, and they look at you like you have a third eye and say, is this how I'm supposed to send this? And you say, yes. So, but yeah, so it flew on the space station in April 2022. We learned tons and tons of lessons. We learned lessons about, deciding if you want to use hard drives versus SSDs, solid state drives. Well, solid state drives don't have the disadvantage of having, what's the spindle? Well, the spindles, but yeah, what's the mechanism that detects for a drop? What's the gyro? So it has mechanisms. All hard drives pretty much have like this gyro that is intended to detect something dropping, and all hard drives pretty much come with it now, and they lock the spindle up just immediately to protect your data. Well, microgravity, you're always falling, so it would not work, typically speaking. So you have to battle that type of thing, which is interesting. Turns out, I think it's pretty known facts that SSD drives and their drivers, the hardware controllers that typically work with SSDs, for some reason, are a little more susceptible to radiation poisoning. It's like there's metrics out there explaining this. So we learned tons of weird, insights such as that while we did this. Oh, yeah, thank you. So you might be asking yourself, why is it orange? It's not for aesthetics. It's not that much prettier. But that is what is called Kapton tape, and I believe it's a brand. I think when you call something like duct tape, it doesn't have to be duct tape made by duct, but that is a brand. It's a type of tape that is known for its insulation properties. What else? It has 2 or 3 other properties that are interesting and important, but for this use case, it was designed for insulation purposes. So they wanted to make sure that it didn't, worst case spectrum, this thing overheated, the fan locked up, it might produce, touch temperatures over what NASA would want. An astronaut going over and grabbing it. The worst case scenario, it would just be hot to the touch. They just wanted to mitigate any possible reason, so we said, fine, we'll just put Kapton tape on this thing. That was the only change that we made to this commercial off-the-shelf product so that we could fly it, which was kind of neat. Am I forgetting anything? All right, so shortly after we powered it on, this is an interesting fact, I think it's interesting at least, is first time I commanded this thing, check on my daughter, she's awake in the middle of the night. I go into my office, and we're doing like a 3 a.m. commanding window. And so I'm literally in my PJs, sitting in my home office, and we power this thing on, have MLA, the astronaut, float over to it and hit the power button, test everything. And I'm sitting here, basically running commands, not quite literally, but close. And I'm running commands on an edge compute device on the space station. And it just kind of hits me, like, what? This is so surreal. It was neat for me. Oops, was that me? One note here, I believe Bill Nelson is retiring, right? I think someone else is coming in to stand in for him, but the administrator, the NASA administrator at the time, said this, made a point to call out the AX-1 mission, that it was pivotal. It was the very first all-private astronaut mission to the ISS, which I've already touched on. So the one thing I'll leave you with here on this is the snow cone currently exists on the ISS. It's floating now. Axiom Space is currently running demonstrations with customers, their customer, our customers. Run cybersecurity demonstrations, transmission, like comms type technology demonstrations typically. We've run 3 so far. We have plans to run more. I quite literally want to advocate that if anyone or their customer wants to, or their company that you work for wants to run a technology experiment on the ISS, please reach out to me or Axiom Space. They're very much interested in working with people to prove out, in particular, if you have a capability that you think a commercial LEO, low Earth orbit destination provider like Axiom would need in their, in their work, that they're planning to do, please reach out to them. We'd be happy to entertain doing a demonstration.